Hi there, and welcome to this lesson on Pure Mathematics 1. In this lesson, we'll be looking at how you calculate the area of sectors and how you calculate the area of segments by using radians. First of all, calculating sector areas. Now, again, we'll do something similar to what we've done in the last two lessons, where we consider what proportion of the circle we have here. In terms of the area, we've got that area out of the area of the whole circle. So A divided by pi r squared. And that proportion will be the same proportion as we have with the angle. The angle we have is theta, and the total angle at the center is 360 degrees or 2 pi radians. So those proportions have to be the same as each other. A out of the total area must equal the same fraction as theta out of the total angle. Rearranging that gives us A equals pi r squared theta over 2 pi, and then cancelling the pi's gives us the formula for the area of a sector, which is a half r squared times by theta, where, as always, theta must be measured in radians. Okay, let's have a look at an example using this. So calculate the area of the shaded sector in the following diagram, where the angle is measured in radians. I'll let you have a go at this, pause the video, come back to me again when you're ready. Okay, let's have a look. Well, we're just using the formula and substituting in the values. We know what r is, we know what theta is, so we can put both of those things into the formula, which gives us a half 3.4 squared times by 1.2, and that gives us 6.936 centimeters squared. Okay, example 2. This time we're told the area of the sector is 8.5, and we're told the angle at the center. The angle is 0.8 radians. What we're asked to find is the radius. We're still just using the formula, rearranging it, and then working out r. I'll let you have a go, pause the video, come back to me again when you're ready. Okay, let's have a look. So that is the formula. We substitute in what we know, and we know A and we know theta. So that means 8.5 is a half r squared times by 0.8. Rearranging that will give us r squared equals 21.25, and finding the square root of that will give us r equals 4.61 centimeters to 3 significant figures. Okay, finding the area of a segment. First of all, what is a segment? A segment is like the shaded area you have there. So you'd have a sector of a circle, you join the chord PQ, and this little part here on the outside is what is meant by a segment. Now, the way we find it is, first of all, we find the area of the whole sector. So like we were doing just now, the sector OPQ, which is a half r squared theta. And then we take away this triangle. Now, the area of that triangle we can find using the area rule, a half AB sine C. And we know the radius, hopefully we know the radius here, we know theta here. So the area of that triangle will be a half r squared sine theta. And then the area of the segment is one thing take away the other. So the sector take away the triangle. That'll give us a half r squared theta minus a half r squared sine theta. And that is what I'd normally remember on these questions, that the area of the segment is the whole sector, take away the triangle, and you find the area of the triangle using the trigonometric rule, a half r squared sine theta. Or it is possible to join these together to get a formula for the area of a segment. And by factorizing that, we can get the formula. The area of a segment is equal to a half r squared into theta minus sine theta, where, as always, theta must be measured in radians. Okay, well, let's have a go at using that. So have a go at finding the area of the shaded segment in the diagram. Pause the video, have a go, and come back to me when you're ready. Okay, let's have a look. Well, the area of the segment is the area of the sector. Take away the area of the triangle. The area of the sector is a half r squared theta. The area of the triangle is also a half r squared. It's a half AB, but A and B are both the radius, so you get a half r squared times by sine theta. Putting in the numbers gives us that, and from here on it is really just a calculator question. That simplifies to 5.76, take away 5.523, which gives us an area of 0.237 centimeters squared for the segment. Okay, the last example, find the area of the shaded segment in this diagram. In this question, we haven't been told the value of theta. So the first thing we're going to have to do, a bit like a question in the last lesson, is we're going to have to use this triangle OPQ to work out the value of theta. I'll let you have a go at doing that, pause the video, and come back to me again when you're ready. Okay, let's have a look. We find angle QOP by using the cosine rule on this occasion. We could possibly have done that in the last example, actually, in the last lesson. And we know the three sides. We want to know this angle. So we can just use the cosine rule, that 4 squared must equal 5 squared plus 5 squared minus 2 times 5 times 5 times by the cosine of this angle here. That gives us the cosine of angle QOP is equal to 50 minus 16 over 50 when we rearrange this. That gives the cosine of QAP is equal to 0.68, which means this angle at the center here is equal to 0.823 radians. Now that we know that, then the area of the segment is the area of the whole sector. Take away the area of the triangle, OPQ, which is a half r squared theta minus a half r squared sine theta, which gives us half times by 5 squared times by 0.823 that we just calculated, minus a half times 5 squared times by the sine of 0.823. It's just calculator work from here on. That gives us 10.2875, take away 9.1649, which gives us an area of 1.12 centimeters squared to 3 significant figures. Now, this really is the last question this time, and it's quite a lot more tricky than the ones we've been doing up to now. So in the diagram, we've got 2 circles, both of which have radius r, and the center of each circle is on the circumference of the other circle. So the center of this right-hand circle here is on the circumference of the left-hand circle. The center of the left-hand circle is on the circumference of the right-hand circle. And what we're asked to do is prove that this yellow shaded area is equal to r squared over 6 into 4 pi minus 3 root 3. Now I'll get you started on this question and then let you try and finish it off. The way to start is to look at this shaded area in some detail. And what we have is this. So joining together the 2 centers and also joining the top and bottom will give us that. And this right angle triangle here, we know that this distance is r because it's the radius of the circle center B going to the circumference. But also we know that this total distance between the 2 centers also has to be r, because from the center to the circumference has to be r, which means that this distance here, OB, is a half r, r over 2. Now, I'll let you have a go at moving on from there. So pause the video, have a go at this, and then come back to me when you're ready. Okay, let's have a look. Now, as always with these questions, we do want to know the angle that we're going to get inside the sector. That means, first of all, working out angle x. Now, the cosine of x is the adjacent side over the hypotenuse, which is half r divided by r. But the r's helpfully cancel, and that gives us the cosine of this angle is equal to a half. Well, that means x is equal to 60 degrees, or pi by 3 radians. Now that we know that, we can put pi by 3 in there, and we'll include this bottom point C, and we want to work out the whole of this angle, ABC. Well, it'll be double that, because the whole thing is symmetric. So this angle will be 2 pi by 3 radians. Now that we know that, we're just going to use the standard method for working out the area of a segment, which is the area of the sector that you would get, take away the area of this triangle. So the area of the orange segment is the area of the sector, which is a half r squared theta, take away the area of the triangle using the rule, the trigonometric rule for the area of a triangle. Now in this instance, that'll give us a half r squared times by 2 pi by 3, which is what this angle is in radians, minus a half r squared times by sine 2 pi by 3. Now the sine of 2 pi by 3 is root 3 over 2. And then we can factorize this expression, taking the half r squared outside. That'll give us 2 pi by 3 here. And as I say, root 3 over 2, because sine 2 pi by 3 is root 3 over 2. We want to know the whole of this area. Well, the whole of this area will be double what we just did. So that's 2 times this. That gives us r squared. And when we join together these two fractions here and make 6 as a common denominator, we'll get 4 pi minus 3 root 3 over 6. And glancing up at what we're trying to prove, all we need to do now is take the 6 outside as the denominator of the fraction, and that'll give us the total shaded area is r squared over 6 into 4 pi minus 3 root 3. Well done if you managed to prove that yourself. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 142 and have a go at exercise 7C. Thank you very much for listening, and cheerio.